Hey everybody, this is Thursday if you are in first period. It is Friday if you are in sixth or seventh period. Before I start today's lesson, I want everybody to go back anything and everything we have done this chapter so far. So that's since our latest test. Anything we've done since then, that's IXL assignments, that's worksheets you've had in OneNote, just anything you haven't completed, go back and check to make sure, or if you haven't completed something, go back and get it done today. All right, today's a great day to make that happen. All right, so with that being said, let's get on to today's topic. Just to review, last time we talked about slope. We talked about how the lower the slope, the flatter the line, the steeper the slope, the steeper the line. We compared it to the green slopes when you go skiing. That'd be the flatter line. The black slopes when you go skiing would be the steeper lines. So you can see here we have a slope of 2, that's flatter. A slope of 1/2, that's flatter than even 2. 1/3 is smaller than 1/2, so it's even going to be a flatter line. And then 8x, right, that's steeper than 2. So you're going to end up with lines looking like this when they're steeper and this when they're flatter. And we said you can find the slope algebraically or graphically. We talked about slope being rise over run. Rise is the vertical change, the change in y. Run is the horizontal change, the change in x. So we said delta y. Delta is a Greek letter that means change. Change in y over delta x, change in x. And we said you can find it graphically. And we had this example, and we just counted. We counted up 1, 2, 3, 4. So that gave us a change in y of 4. And then we went to the right, 1, 2, 3, 4, 5. So the denominator was 5. So it's your vertical change. In this case, we went up. That's the positive y direction. Over the horizontal change, we went to the right. That's the positive x direction, 5. Now, if you started at this line over here, you would go down 1, 2, 3, 4. So that's negative 4. And then go left. That's the negative direction as well. Left 1, 2, 3, 4, 5. So you end up with negative 4 over negative 5, which is the exact same thing as 4 over 5. You should always simplify it and write it as 4 over 5 in this case, not negative 4 over negative 5. You're not wrong here. It just can be simplified a bit more. It'd be like saying the slope is 2 over 4. You should simplify 2 over 4 to be 1/2. And then here was another example. We worked with that. Again, just counting rise over run, change in y over change in x. And we got negative 6/5 here. Same thing here. And then we talked about the slope formula. Slope formula was y2 minus y1 over x2 minus x1. So here we had two order pairs. It didn't matter what you called x1 and what you called, or it didn't matter what you called x1, but whatever you called x1, it had to be paired with y1. And then the other order pair would have to be x2 and y2. So whenever you have a set of order pairs, identify one x as x1, it's paired with y1, and then the other x and y are x2 and y2. And then just simply plug it into the formula y2, which in this case was negative 5, minus y1. Y1 is 5. So negative 5 minus 5 is going to give us negative 10. And then x2. X2 is 4 minus negative 2. So yes, we do have to subtract the negative. So remember, when you subtract a negative, you add. So it looked like this initially. 4 minus negative 2. Again, x2 was 4 minus x1, negative 2. You subtract negative 2, that means you have to add, right? So 4 plus 2, we get positive 6. So here we had negative 10 over 6, which simplifies to negative 5/3. These were all examples we worked yesterday. Here was another example of the slope formula, just working the slope formula and yeah, identifying x1, y1, x2, y2, plugging it into the slope formula. There you go. Now, there was an example down here where we found the slope, and we said the slope was negative 7 over 0. Notice when we have a denominator of 0, that's undefined. We can't divide by 0. We learned that, I think, back in term 1 maybe. We can't divide by 0. That's undefined. This is always going to be a vertical line. So if you were to graph this line, it would come out to be a vertical line. Vertical lines fail the vertical line test. So maybe that's how you can keep it straight in your head, that it's undefined because it's not a slope. If you ever get a slope of 0, that would be the numerator is 0. That would be a horizontal line. Horizontal lines have a slope of 0. Vertical lines have a slope that is undefined. Now, let's talk about parallel lines. Parallel lines, they never intersect. So what's the relation between the slopes of parallel lines? they are the same. This is the new information today, so if you've checked out, check back in right now. Parallel lines are the same. They never touch, they never cross, but they are the same slope. Same slope. There you go. Linear equations. A linear equation can be written in slope-intercept form. Okay. Y equals mx plus b. We talked yesterday about how m is the slope. So that should not be new to you, the fact that m is a slope. B is what we call the y-intercept. Think about what it means to intercept something, right? So if you intercept a pass in football, you catch it, right? So like if you're on defense, the quarterback throws the ball, and you jump in the path of the ball and you catch it. So you touch the ball, you are in the path of the ball. Y-intercept would be um, on a graph here. If we had a line, let's say this is 1, 2, 3, and 1, 2, 3, and 1, 2, 3, and 1, 2, 3. So let's say we had a line that passed through 2 here. Well, if we had that line, that has a y-intercept of 2, right? Y-intercept is equal to 2 there. So you would say B, your y-intercept is represented by B, is equal to 2 in this case. What if we had another line that looks something like, I don't know, maybe something like this? Well, this crosses where? That crosses right here at -2. So you would say B equals -2. The y-intercept is always on the y-axis. It's never on the x-axis. That's called the x-intercept. Okay? So now let's go to IXL. We're going to go to V.4. V.4. Watch this first before you work it. This won't take you long. Find the slope of the line. Well, this is in slope-intercept form, right? Y equals mx plus b. Y equals mx plus b. 3/11ths right here, the coefficient of x. 3/11ths. That is your slope. So you would rise 3 and run 11. Here, y equals mx plus b. M is the coefficient of x. 12 is the slope there. Y equals mx plus b. M is 10. 10 is the slope. 9/4 would be the y-intercept, by the way. It's as simple as that. Y equals mx plus b. Slope-intercept form. Slope is 1/2. Rise 1, run 2. That's your slope. 1/2. I'm just going to work a few to see if these get any more difficult. Looks like they don't get more difficult. You can do this probably in about 1 minute. I'm just going to go ahead and get all the way through just to make sure. Yep, so it's as simple as that. These are all in slope-intercept form, so pause the video now, go work V.4, find the slope of each line, y equals mx plus b. Okay, now let's go on to IXL V.5, graph a line using the slope. Okay, so graph the line that has a slope of 1/2 and includes the point 2, 1. Okay, well, the point 2, 1 is right there. 2, 1 is right there. Let's plot that. Left click to plot it. Slope is 1/2. That means we rise 1 and run 2. Boom. There you go. There's your line. Graph the line that has a slope of 1/5 and includes the point 0, 2. 2 right there. Rise 1, run 1, 2, 3, 4, 5. There you go. There's that line. Graph the line that has a slope of 1/7 and includes the point 0, 0. Well, there's 0, 0. We're going to rise 1 and run 1, 2, 3, 4, 5, 6, 7. Graph the line that has a slope of 5 and includes the point 0, 1. Well, 0, 1 is right there. 5 means we're going to rise 5. 1, 2, 3, 4, 5. And we're going to run 1. There you go. All right, I think you got this. So go ahead and work on this. Plot the points and graph the line. I should add, I want you to get to 100 on all these IXL assignments today. All right, last IXL assignment here. We're going to go to V.6. V.6. Please watch this before you attempt it. Look at the graph, it says. So here we have a graph. What's the equation of the line in slope-intercept form? Okay, so we need two things for slope-intercept form. We need the slope and we need the y-intercept. Y-intercept here, you can see We cross at negative 1,000. So that's going to be B. So let me get my pen out here. Okay. So if you recall, this is y equals your slope, m, multiplied by x, plus b. So we know that b is equal to negative 1,000, because that's where it crosses the y-axis right there. So what we need is 2 points so we can find the slope. Well, I got this point right here. Now, each of these squares are different, so be careful. Well, are they? Let's see. If you go down, they're 100 apiece, right? Negative 100, negative 200, negative 300. If you go to the right, 100, 200, 300. Yeah, they're 100 apiece. Every square is 100, right? So to go from one point to the next, up 1, right 1. So that's 100 over 100, which is equal to 1 over 1, or just 1. So 1 is equal to our slope. So that means y equals m, which is 1, multiplied by x, plus b, well, plus negative 1,000. Hang on one second. Plus negative 1,000. We can write that as subtraction, right? And I also don't have to show this 1. So we're going to change that to subtraction there. And we're not going to write that 1. So it looks like this. Y equals x minus 1,000. Y equals mx plus b. Negative 1,000 is my y-intercept. My slope is 1. By the way, when the squares are the same, you can treat them like they're squares of 1. Rise 1, run 1. Each square is worth 100 in either direction, so that's a little shortcut you can take. You don't have to actually do 100 over 100, but I wanted to show you it still works the same. So there we go. Let's do a couple more together before you go on your own. So y equals mx plus b. Okay, well, where does it cross the y-axis? It crosses at 0, so b equals 0. And then what's another point that we have? We got a point up here. Be careful on this. Looks like we crossed there. So we got to go up 7 and to the right 1. So your slope, you go up 7 and right 1, which is 7 over 1. That's just 7. So y equals m, 7, multiplied by x, x, plus b. That's plus 0. We don't have to show that. So we're just going to say y equals 7x. And then submit. Let's try another. Where's the y-intercept? Y equals mx plus b. B equals negative 4. So we got this point right here. And each square is worth 1, right? We got that point right there. You could choose any 2 points. They don't have to be that close to each other. Just for fun, I'll show you that I could use that other one over there. But hopefully you can see what the slope is going to be right now. I'll use this point right here. This is called the x-intercept. Hang on. Right there. So we're going to go up 1, 2, 3, 4. We went up 4. And to the right, so 1, 2, 3, 4 up, and to the right 1, 2, 3, 4. 4 over 4, which is 1. So y equals slope, which is 1, multiplied by x, plus b, plus negative 4. So we can write it as subtraction. You could write plus negative 4, that's fine. But I'm going to write it as minus 4. Y equals x minus 4. There you go. Let's try one more, and then I'm going to send you off on your own. M equals b equals, well, b is, I can see negative 60, right? This point right here. Every square is worth 10 in either direction. And right there, we got another point. So up 1 over 1, slope is 1. So y equals 1 times x is just x, plus b, plus negative 60 is minus 60. I want to find one where the slope is left like a fraction. So this one's a little different. This one's got a negative slope. you can see it crosses the y-axis at 0. And then we've got to go down 1, 2. Let me first identify another point right there. So I've got to go down 6 and right 1. So if we go down 6, that's negative 6 over. If you go right 1, that's positive 1. Down 6, 1, 2, 3, 4, 5, 6, that's negative 6. To the right 1, which is just negative 6. So y equals negative 6x plus 0. Y equals negative 6x plus 0. Okay. All right. Well, good luck on this. Get to 100, please.